Hi everyone, today we are going to start 4.6, which is prove triangles congruent by angle, side, angle, and angle, angle, side. All right, so once again, here's a big review of what we need to know to be able to prove that triangles are congruent. So the last two that we're going to talk about today is angle, side, angle, and angle, angle, side. Angle, side, angle. If two angles in the included side of one triangle are congruent to two angles in the included side of a second triangle, then the two triangles are congruent. So if I look at my example here, we have angle, side, angle, and angle, side, angle. So those two triangles are therefore congruent. Angle, angle, side congruence theorem. If two angles of a non-included side of one triangle are congruent to two angles in the corresponding non-including side of a second triangle, then the two triangles are congruent. So we have two angles here, and then we have a side that is not in between those two angles. So same thing here, I have a congruent angle, another congruent angle, and the same side that's not included inside the two angles. Then we have angle, angle, side. Can the triangles be proven congruent with the information given in the diagram? If so, state the postulate or theorem you would use. All right, so let's look at the first diagram here. So I see an angle and an angle that's congruent. I see a side and a side. But this isn't enough information. We need three terms here. However, I do know that these two angles are congruent because they're vertical angles. So this is yes, these two triangles are congruent. Why? Well, this is angle, angle, side. So we have angle, angle, side, angle, angle, side. All right, for B, if we look at the triangles in this umbrella, are these two triangles congruent? And we're going to say no, there's not enough information because all they give us are three angles. And angle, angle, angle is not one of our 5 congruent theorems. C, all right, so I have one angle here, one angle here. Those are congruent. I have 2 tick marks here, 2 tick marks here, which means those angles are also congruent. However, I only know 2 angles here. Is there anything else that this diagram tells me that I can use for my congruence theorem? And the answer is yes. I see that both of those triangles share that side, which means if they share the side, it is congruent. So this is enough information to prove that those two triangles are congruent, and we can prove that they're congruent by angle, side, angle. All right, so let's do a proof. So prove the angle, angle, side congruence theorem. We are given that angle A is congruent to angle D. Angle C is congruent to angle F. We want to prove that, and that side length BC is congruent to side length EF. We want to prove that triangle ABC is congruent to triangle DEF. So what's the first thing I'm going to write in my proof? Always the given. So angle A is congruent to angle D, and we know that angle C is congruent to angle F. That was given. And even though it's already written in my diagram, I'm going to trace it again. So angle A is congruent to angle D, and angle C is congruent to angle F. All right, we also know that BC is congruent to EF, and that was also given. So that's what these tick marks are for, telling us that those segments are congruent. All right, well, next, we know 2 angles in the triangle. 2 angles here, we know 2 angles here. Well, if those 2 angles are congruent, we therefore then know that B is congruent to E, those angles have to be the same measure, because what does a triangle sum add up to? 180 degrees. So number 3, we know that angle B is going to be congruent to angle E, and that is by the third angle postulate. So finally, we can say that triangle ABC is congruent to triangle DEF by which theorem? Well, we're going to kind of focus right here and focus right here. What theorem is stated here? Angle, side, angle. And I'm done. All right, in our last proof today, in the diagram, CE is perpendicular to BD, and angle CAB is congruent to angle CAD. We want to write a proof here. Okay, so once again, we're given this, and we want to prove that triangle ABE is congruent to triangle ADE. So I'm going to highlight the triangles that we're trying to prove. So ABE is this little triangle right here, and triangle ADE is this triangle right here. All right, so I want to try to prove that those triangles are congruent. All right, so what am I going to do first? Well, I'm going to write out what is given. And I am given, I'm actually going to start with this part here, that angle CAB is congruent to angle CAD, and why that was given. All right, so that means that this angle here is congruent to this angle here. But if I look, those are outside of my two highlighted triangles, so I technically don't really care about those. However, it is going to help me figure out what these two angles are. And I know that those two angles are going to be congruent, so I need to write that down. That is angle actually, we know that angle, I'll start CAB, so the first angle, and our second angle that I highlighted, angle BAE, we know that they are supplementary. Okay, so why do I know that these two angles are supplementary? Well, they're a linear pair. So that would be my reason. Linear pair. All right, so I have another set of supplementary angles, so let's write those out. So angle CAD, the first angle I drew, and the angle with two tick marks, which is angle DAE, they are supplementary. And once again, they are a linear pair. I'm also told in my given that CE is perpendicular to BD, so I'm going to write that for my first step. So CE is perpendicular to BD, and this was given. So that means that these two lines form 90-degree angles. So I need to write that out. So for number 5, I'm going to write out that the measure of angle, which let me scroll up so you can still see the angle I'm talking about. So the measure of angle AEB, which is the purple triangle, is equal to the measure of angle AED, which is the red triangle, which we know is equal to 90 degrees. And that is just the definition of perpendicular. I'm going to abbreviate this. So definition of perpendicular. All right, and lastly, looking at these two triangles, I notice that they share a side. They are touching each other. So which side do they share? They share side AE, and I'm going to try to highlight this for you. Oh, so as you see, they both have the side AE. So let's write that in my proof. I'm not going to change the color, so this is going to be blue for a second. So I see that AE is congruent to AE. What property is that? It's the reflexive property. So my last step then is to say that triangle ABE is congruent to triangle ADE by which congruence theorem? Okay, I'm going to scroll up a little bit. So which congruence theorem do you think is going to work here? Well, it's angle, side, angle. I have an angle here that is congruent to this angle here. I have this side that they both share. And then we have two 90-degree angles. So that is angle, side, angle. So I'm going to write that here. And I am done with my proof.